So I'm going to be going over ways of determining vertical asymptotes, horizontal asymptotes, y-intercepts, x-intercepts of rational and wholes of rational functions. So in order to determine the vertical asymptotes of a rational function, these are actually obtained from all the x values that make the denominator 0. So if you have a x value that you plug into the function and it makes the denominator 0, then that is a vertical asymptote. And it usually has a form of x equals something, something, something. So it can be like x equals 2, x equals -2, 3, 4, -5, anything. Horizontal asymptotes are determined from 3 different cases, and they're right here. So they usually depend on the degree of the function. The degree, again, is just the highest exponent of the polynomial. So in the numerator, the degree is n, and in the denominator, the degree is m. A and b are just leading coefficients, so that would just be the number in front of the variable. In this first case, it says that n, meaning the degree in the numerator, is smaller than the denominator. So if the numerator's degree is smaller than the denominator, then your horizontal asymptote is y equals 0. If, this is another case, if the denominator's degree is bigger than the numerator's degree, if the numerator's degree is bigger than the denominator's degree, then there is no horizontal asymptote. If they are equal to each other, if they have the same degree, then your horizontal asymptote is just y equals a over b. You just take the leading coefficients and you divide them by each other. For wholes are basically determined by anything that gets canceled after you factor it and simplify it after you set it equal to 0, and can be set equal to 0 to be found. So if something cancels out, like for example, if you can cancel out an x over x minus 2 in the numerator and denominator, then you can set x minus 2 equal to 0, and that will give you your whole. So you can set x minus 2 equal to 0, and then that will, solving for this will give you your whole. So then that would mean that a whole is at x equals 2. Same thing if you were to cancel out an x on both numerator and denominator, then that means that you have a whole at x equals 0. And there is there might be a confusing part where you would think that a whole is an asymptote, but it's not. The reason is because an asymptote goes off until infinity. So an asymptote, if you have a vertical asymptote, it usually goes off to infinity. So it keeps going on and on and on and on forever. So this here is a vertical asymptote, but a whole is just a point where the function is not defined. It's just one point that is removed or not included in the function. So a whole is not an asymptote. For the x-intercept, an x-intercept can be determined by just setting y equal to 0, or f of x. F of x is the same thing as y. And you always want to double check to make sure that the x-intercepts that you find after setting y equal to 0 are not wholes or vertical asymptotes. If the x values that you find is also a whole or a vertical asymptote, then that x value is not an x-intercept because it cannot be included, because it is not an included point. The function is never going to reach that point. Also, if you get imaginary x values, then that means that the function is never going to reach that point either, because imaginary numbers are not on the real number line. So that means that there is no x-intercept at that point either. For the y-intercept, you actually want to set x equal to 0. And if the denominator is equal to 0 after you plug in x, then there is no y-intercept, since at that point it is undefined.